Everyone. In this lecture, we are going to talk about an important concept. It's called pointer. Why do we need to talk about this pointer? How important it is? Well, you may not need it that much in this course, but you will definitely uh, will be using it in the next advanced class when we cover advanced topics like linked lists and other topics. But we'll just introduce the topic today. So, what is a pointer? A pointer is a variable. So, we talked about normal variable, right? But the variable that we talked about, they hold a value, like a number, like integer, double. But this type of variable, the pointer, instead of holding values like normal values that you are familiar with, they hold the addresses of this variable, like the location in memory of this variable. So let's have an example here. So let me start with a very simple variable, num, and I'm going to assign it a value of 5. So there is a place in the memory, okay, called num that holds a value 5, okay? So far, this one should not be a complicated thing. Now let me print this variable. So if I put, for example, the value of num is num, then of course it's going to show number 5, right? If I run the program, it's going to show number 5. The value of num is 5, okay? Now, if you want to know the location, the address of this variable in the memory, then I just have to use, so let me put here the address of this variable is like where it is located. So this is just like the houses. Houses have addresses. Every house has an address because without that address, then it's going to be very difficult to locate that place. Or for Google Maps, for example, to take you over there or to show you the instructions or the direction. So this is the same thing. Pointer basically holds the address where the variable is located in the memory inside the computer. So if I want to know the address, I just have to add the symbol, the ampersand, next to the variable now. So now it's going to show me the location. If I run the program, you're going to see that this is the location. That's big. Look, it's a combination of digits and also characters. So it looks like a hexadecimal number. But instead of like remembering this, which is kind of difficult, that's why we use the normal variable because it's easy to remember because we name them, we give them meaningful names, so it's easy to remember. But if we are forced to use the pointer, that's going to be very difficult to remember, for example, this memory address. All right, so basically here we have two ways to access the same thing, which is number 5. Either you are going to use the variable, or you can use the address, because if you know what the address is, then you can find the value. It's like a look at it, it's like a house that has a front door and back door. So there are both ways. It's better to use the front door. But what about if you have a problem? Let's say the lock got mixed up or messed up, or something happened, or emergency, or it's blocking, something is blocking the front door. So what you're gonna do? So you have no choice but to use the back door. So this is pretty much the same thing. So I can use the variable num, or how can I use the address to access that number 5? I can do that. I can create a variable, a pointer. So this is how we create a pointer. We put the data type, it has to match the data type of the normal variable, and then we add asterisk. So the program sees asterisk, it knows that it is a pointer. And then we give it a name, ptr. And it's gonna hold what? The address, which is this. So when you put ampersand, that means the address. That means don't put the value, put the address. So now this is the pointer. It's pointing to the same place. Now, but for me to print or to display the value, I have to use, if I print PTR, that's going to give me the address. I don't need the address. I need the value where the address is located. So I want the value. How can I do that? I'm going to use what we call dereferencing. That means I'm going to use the same symbol. That's going to give me the value, not the address. So now let's print it and see what happens. So I'm going to put here, if I run the program, it's going to give me the same value. Can you see 5, 5? So either you're going to put print num or print asterisk, whatever the pointer is. Two ways. It gives you the same thing. All right. And then this is an integer. Of course, I can create any type. I can create a pointer of type double, char, string, any object. But make sure that the data type of the variable matches the data type of the pointer. They have to be. You cannot do, for example, something like this. Like we have double a grade equals, let's say, 6.5 or 6 point, sorry, like 75.50. Now, I'm going to use integer that's variable. Let's say GR. Now, can I put this? See, it is underlined. That means there is a problem here. Why? Because the data type of the variable is double, but the data type of the pointer is integer. You can do that. How can we fix it? Is by choosing the same one. See that? The same one. Okay? All right. So this is how we create um, a pointer. Now let's make some arithmetic operation. Let's say I want to add 2 to my variable. So I'm going to put num plus equal 2, right? So now when I print the num, of course, let me just use this to print. So if I print num, of course, it will change. It will be what? It will be 7, because now I added 2. Now, since the pointer is pointing to the same variable, then it has to change as well. So if I print this, it should give me the same thing. So if I print this, it's going to give me the same value, which is 7. Why? Because it's like we have two arrows pointing to the same thing. It doesn't really matter which way you go. So again, let's go back to the example of the house. So it is the same house. Whatever we have inside the house is going to be the same. It does not really matter whether you enter from the front door, from the back door. We are talking about the same house. So this is the same thing. Now, can I add to my pointer instead of adding to num? Yes, I can. But again, you have to use the asterisk. You cannot just put ptr plus equal to. Why? Because this is refers to the address. It's like you are adding 2 to that big address that is made of characters and digits. That's not what you want. So you have to use that asterisk. That means I'm talking about the number, the value that this pointer of the variable that this pointer is pointing to. All right. So now I have to put that asterisk. So now I'm adding 2 to 7. Now if I print them again, I'm going to get 9. So it's like two different ways you can change the value. See, it's 9, 9. It does not really matter how you do it. All right. Now let's talk, for example, about some of the mistakes people make. Let's say, for example, sometimes students, they may make something like that. And they declare a pointer. Okay, let's say ptr1, Okay, so they declare, but they never assign an address to it. Okay, we have the pointer as a variable, but it's not pointing to anything that has an address. So now, when you try to put, for example, asterisk PTR1, if you want to assign 7, now we have a problem. Why? Because you didn't even have an address to begin with, and now you are changing the value to 7. That's going to cause an error. If you try to run the program, you're going to get an error. How can we do that? First, define a variable, anything, then make sure you assign it that address. You have to start with an address. So then I'm going to put V. Now it makes sense. Okay? So because now it holds an address, then you can change it to 7 or any other value. So now if I print, it should be fine. See out. If I put whether it's V or or asterisk PTR2, so it's going to print the same value, which is 7. Okay? PTR, I'm sorry, I called it one. Okay? So now if I run the program, it's going to be 7, 7, as you can see. So don't make this mistake. Make sure, like what we did before, we have to make sure you assign it to an address. You cannot start with a pointer that's pointing to nothing. Or, it's an alternative, there is a variable called null PTR that C++ provide that you can use, usually like a 0 or something like that. All right, so you can do that. Now let's move on to another topic about pointer, which is how we can use it in functions. You can see the difference. So let me basically just stop all of this. And then I'm going to create a function to show you how the pointer is different than using a variable. So let's say I want to create a function, or what it does, it just double the value. So let me start with the variable, and then I will use it with the pointer so you can see the difference. So let's say there is a function called double up. It takes, okay, a value, and then it will multiply by 2. So val times equal to. So if this function takes number 5, it will change it to 10. And then I'm going to print it. Okay? So I'm going to put here val. And then add. All right. Now if I try to call this function using num, so I'm going to do double up. And then I'm going to call this function using num. Num is an integer and val is integer, so it matches. Let's see what's going to happen. What's the output? So I have 10 because it must multiply 2. Now, what about the value of 5? Did it change? Let me print num and see if there was any change. Did it affect the original? So if I run the program, you're going to find out it did not change. Num is the same. It did not change. Why? Because we just copied the value. We did not affect the original object. I'm going to give you an example in case you guys confused here. Let's say I have A equals, let's say, 9. Okay? When I put B equals A, that means I'm copying the value of A into B. But if I change B, does it affect A? If I put B plus equal 2, now does this affect A? Of course not, because I just got the number 9. I copied A number 9 and I assign it to B. So when I add B, it does not affect A. It's the same thing here. So I copy the value 5 from num and I give it to val, which does not affect num. Just like this does not affect A. It's the same thing. Okay? So, but when it comes to pointer, it's a different story. Why? Because we are using the address. So you are changing the core, you are changing the origin, the source of the where the value is coming from. So now if I have another function, void double up, and then I use look integer, a value. So that means I'm using a pointer. Okay, now I'm going to multiply that value by 2, like what I did. But I'm going to use, so the difference, right? I have to use this. Why? Because if I put value multiply, this, I'm using the address. I don't want to use the address. So we have to use the asterisk. That means I'm talking about the value. If I put multiply by 2, and then I print it, say out. Okay. And when I put value, so you're going to see, let's see what's going to happen. So I'm going to double up, and then I'm going to use the ampersand because remember, it accepts address, not a normal value. So I'm going to put here num. That means the address of the variable num. So now let's see what happened. And then I will print num after that. Let's see out. So let me run the program and see what happened. So the value did change because in the first one, in the first function, num was 5. It never changed. But look at the second one, 10, 10. That means it was changed. Why? Because if you change the address, you are changing the origin, the source of the where the value is coming from. All right? So that's the difference between using a normal variable, you are just copying the value, but if you are using the pointer, you are affecting the source. You are changing the actual object. Okay? Now let's end with the relationship between arrays and pointer, because there is a strong relationship between the two. Actually, an array is nothing but a pointer, believe it or not. So let me delete this, and then I'll give you an example. Okay, so let's come up with an example of an array. So let's say we have grades. I have 5 of them, and then I'm going to mention some of them here. So let's say 75, and then 82, 96, and then 60, and then 100. So this is an array, right? So now let's say I want to print one of these values. So I'm going to put C out, let's say the first one. If I put grades 0, it will print. Let me just make sure that it's balanced to 1. So if I run the program, it will print, of course, the value 75 because that's the first one. Now, a pointer, there's a strong relationship. A pointer, the first element, an array is a pointer. Okay, it's a pointer. So if I use the pointer, I can point to the first one. So for example, if I put, look, grade 0, if I put ampersand, grade 0, it's going to show me the same thing. Look. Now I'm going to print the grade. Okay, before I do that, let me show you here. If I print the grades, it will show me the address of the first element only. Yeah? So this is the first element. So an array is the pointer pointing to the first element. Now I can use the pointer as well. So I can do this. I can put the ampersand grade 0. That's going to give me the pointer as well. So if I run the program, see, it shows me the same. That shows you it is exactly the same. Whether you are using the name of the array or the pointer, it's the same thing. Which means there are two ways you can access the elements in the array. I can, for example, let's say, let me print all the values of an array. So I can start from 0, grades dot length, or just 5. Just put 5. And then I plus this. So if I print, there are two ways, right? The one that we're familiar with, you put grade I. So create 0, and then I'm going to leave a space here. So this will print all the elements of the array. If I run the program, it's going to show 75, 82, 96, 60, 100. But there is another way to print the array, but this time using the pointer. So I'm going to print the elements of the array using pointer. Okay. Now I just showed you like a minute ago that we can create a pointer to point to the first one. So if I put, for example, PTR grades, this is means that I'm declaring a pointer that points to the first element where the 75 is. Okay. So now, if I want to print the element using a pointer, I'm going to do the same thing: 0, less than 5, less plus plus. And then I'm going to print C out. Pay attention here, but let's make sure I start a new line here. I'm going to put C out, but pay attention here. I'm going to put asterisk and then PTR. So this will print the first one. What about the second one? I'm going to keep adding I. And then make sure you put the parentheses. So that means the first one, I'm dereferencing every single. So PTR 0, it would be the first one, 75, and then dereference it. And then go to the second one. So plus 1. That means the next element, depending which type. Like here we have integer, so we are going by 4 bytes. 4 bytes, 4 bytes. So every time you add, so this will give us the same thing. So let me just leave a space here. And then you're going to see it is exactly the same thing. See? Why? Because PTR, remember, is the pointer. So when you put plus 1, that means the next. That means pointer is pointing to the next element, to the next one. And then I'm dereferencing each one of them. Okay? Now there is a third way to print. Print the elements by dereferencing. As I mentioned, you're not going to use the pointer a lot here. Probably that's the only chapter we're going to be talking about pointer. But you may need it later on, probably in 1437 and 2436 classes. So how we can print? So I'm going to go here and then again, I'm going to create a variable pointing to the first one. I have to start from. So I did say I'm going to put here, I'm going to create a variable ptr1, again pointing to the first one. And I'm going to use the loop I less than 5, I plus plus. So now I wanted to print every single element. I just have to put asterisk PTR1. Okay. So that's going to print the first one. What about if you want to move to the second one? I just have to increment it. So I'm going to put PTR1 plus plus. That means move to the next element. So this is going to print every single element. Let me make sure they are separated by space. All right. And then also make sure that this is start new line. So what's going to happen here? Again, it's going to print the same thing. Look. So the first time or the first line, it was a normal gray. We use the what we know about arrays, right? The second one by incrementing by I, okay? And then the reference. The third time is just by using the pointer and incrementing it every time. See? So that's what we have here. Okay. So this is a basic, like an introduction to the pointer. I hope you find it useful. If you have any questions, please let me know.